to have Dr. Ballard here today. And he is a wealth of information and a great asset in the medical community. Dr. Ballard became a registered nurse in '77. He became an ND in 1982. He's one of the first graduating classes, or are you actually in the first?
I'm the first.
He's in the first graduating class of Bastyr. I mean, how many people can say that? You probably know, actually, how many people can say that.
Not very accurately.
Yeah.
Dozens, 12, 15.
Yeah. See, that's incredible. Dr. Ballard has numerous publications and numerous media appearances. He runs Pure Wellness Center, which is a detox and nutritional rejuvenation program. He also runs a company called Pure Weight Loss, which is a blend of detox nutrition, activity, and DNA information that's used to achieve vital health and also weight control for people. He practices green medicine and has work that he does with that, which is promoting effective, sustainable, organic healthcare. And most recently, he's added Natural DNA Solutions, which offers medical reports that enable people to turn their genetic data into life-changing actions. So people do, and he'll talk more about this, but it's really empowering work that he's doing, and he'll be able to talk more about that. But I wanted to give you a short, this is a short intro for what we could say for Dr. Ballard and everything that he's done in his career. And again, we're so lucky to have him here today. So let's welcome him.
I think what's confusing to a lot of people is they sort of see naturopathic medicine, they either don't know anything about it at all, or they kind of see it as this sort of weird fringe medicine. And the way I explain it to my patients is that we go to 4-year medical schools, we do anatomy and physiology, biochemistry, but instead of looking at signs and symptoms and drugs and surgeries that focus on signs and symptoms, we're really looking at the cause of disease. And so that's been my goal for 32 years, is to try to find out why people aren't feeling well. And so it's more than just, substituting a vitamin or an herb or a drug, but it's really kind of looking much deeper than the dominant medical system is doing. And that's why I was really excited about this whole business of DNA and making it available for people. Because one of the things that DNA analysis has done for us is it's validated my medicine and validated what you do. There are more genes coding for nutrition and detoxification than any other process in the body. And I think that kind of speaks to how important those things are and how we need to know much more about those to get people healthy. So if you don't know a little bit of the background of this, 23andMe is probably the predominant company for consumers doing their DNA now. They've been around since, I think, 2009. Yes, really early. And it's really remarkable when you think about this technology, because it was just about that time that the Human Genome Project was unveiled, and that cost millions of dollars. And then within a few years, companies like 23andMe were offering home test kits where people could do it for $10,000, and then the price dropped down to $1,000, and then for several years it was $250. And then a year ago, they dropped it down to $100. This is amazing. This is less than it would cost you to get your cholesterol tested or something like that. It's truly amazing. And it's a saliva sample, and this is just one of their test kits. In here, there's a little plastic vial that you salivate into. You send it off to them, and 4 weeks later, you have your whole genome sequence. So, pretty amazing technology. The one limitation of this has been, that they don't offer any kind of health analysis. What you get with that is information about your genealogy, how much Irish you are or whatever, how much Neanderthal you are. I'm 3% Neanderthal, in case you're wondering. And then some general genealogy kind of information. But they are forbidden from the FDA, by the FDA from giving any kind of nutritional or health information. They originally did, but the FDA said, we don't want you to do that. And so for that reason and for other reasons, I set up this business, Natural DNA Solutions, basically take that genetic information and turn it into a report that people could use to change their health. And this is always where I want to point out the little mouse picture on the front, because this is what most people haven't quite gotten through their heads yet, which is your genetics are not fixed. You know, your genetics are a blueprint, but you change how you manifest your genetics, and that's called epigenetics. And this is a great little example, and it's too bad this isn't a color photo, but what you have here is two mice. The one on the left is big and fat and blonde and diabetic. And this is actually a strain of mice that are bred to be that way. This is how a lot of research is done on diabetes, is they take these mice that are genetically modified to manifest diabetes, and then they do various experiments on them. So what this guy did, looking at the epigenetics, is say, let's take two genetically identical mice. So these are two of the exact same mice, but you feed them a different diet. So you have the one that's eating the typical mouse chow, rat chow kind of diet, and he continues to be obese and blonde and diabetic. But the one who's eating a healthier diet is normal size, has a dark coat, and doesn't have diabetes. So this is just sort of a graphic, you know, and if you Google epigenetics in rats, you'll see many of these kind of pictures on there. It's quite amazing, and it's a great way to sort of demonstrate to patients, you know, why they can actually do something about their genetics. So as I already mentioned, I think that genetics sort of vindicates my kind of medicine and what you do. And I've kind of boiled it down there on that first sheet to this idea that detoxification, nutrition, and activity are the three things that come out over and over again when you look at people's genetics. And when I say activity, I mean that kind of in the broadest sense of the word. Yoga, exercise, mental activity, all of those kind of things have an effect on our gene, as does nutrition, as does detoxification. So it makes a great little mnemonic. That's DNA also. So DNA supports your DNA. So one of the things I want to do today is just kind of run through some of the highlights of this kind of testing, and you know, if you decide to do this sort of thing with your patients, you'll have a kind of a clue on how to do this. But basically, the report comes in 4 parts. The first part is an introduction. Second part is a graphic representation, which you have a very small little snippet there on page 3. I just gave a couple of examples, but this is actually quite a long graphic representation of it, and here you go. So we have pages and pages and pages here. And I don't show you this to overwhelm you, but to sort of orient you to what's going on here. What we have is the genetics of the person organized, loosely organized. So here in this first column we have this particular instance of detoxification. So we then have a bunch of genes that look at detoxification. And I'll explain a little bit more about that in a little bit. And then you have another section here. This is tongue-tied and cleft palate. These are genes that have to do with that. There's one here for IgG. There's one for IgA, et cetera, et cetera. There's methylation. There's mitochondria, et cetera, is how this is sort of roughly organized. And I say roughly because it's not like we imagine in movies and sometimes in medical offices where it's like one gene codes for this, and oh, you have this gene, so you're going to get diabetes, or you have this gene. That's not very common. That's very, very rare. What you usually have is a group of genes that code for something, and a combination of those genes plus how you live your life determines what's going to manifest. And so, for instance, under eye health here, there's some genes that code for vitamin A. Actually, what they do is they code for an enzyme that converts beta-carotene into vitamin A. And if you're weak at doing that, then you're not going to produce enough vitamin A, perhaps, to help with your eyesight. But as you know, vitamin A also does other things. So that's why I say this is kind of a loose organization. This goes on and on. So, kid, I don't want you to be overwhelmed by this, but if you see these, it's actually, all you do is sort of break it down into its components. So if you were going over this with one of your patients, you basically skim over this and say, well, what are the different areas and how does this relate to how this person has been feeling? And then you look at the color coding. So the color coding here is very important, and I put a little bit in here about genetics. I don't want to get into it too much. I'll be glad to answer questions if you have them. But basically, we have what we might call a normal gene. That would be green in our coloration here. Yellow is when you have one abnormality or one bad allele, and red is when you have two bad alleles. You know how this is. It's hard to use these words bad and good, because what we're finding is that there are just some that are more normal and some that are less normal. And these don't necessarily code for diseases, they just code for differences in how you perceive the world. Actually, an analogy I love is that genetics is the blueprint, that you decide how to read the blueprint and how to build your house. You have to pound the nails and saw the boards and measure the boards and saw them and do all those kind of things. And the house, each person's house is going to turn out differently, even with the same basic blueprint. So if you were looking at one of these, I'd say the first thing to do would be to go through and kind of look at the sections, detoxification, methylation, and whatever. And on your right-hand side here, you have an explanation of what that gene does. Does it affect vitamin D? Does it affect vitamin A, et cetera, et cetera? And then pick out the reds. Those are the ones you want to first look at. The AO gene codes for an enzyme called diamine oxidase, which then breaks down histamine in the body. So we're going from food, which we know, and we'll be talking in more detail about this in a little bit, that there are certain foods that have histamine. There are certain foods that are histamine releasers. Those are going into the digestive tract, and if they're not being broken down, then you're going to have a buildup of histamine in the system. Whereas if this DAO enzyme is working, it's going to be breaking down that efficiently. So that's your basic kind of overview, and that applies to all of these. So red ones are going to be less likely to be effective. Green ones are going to probably be working pretty well, unless somebody's really messed them up along the way by environmental toxins or other sorts of things. Probably maybe seen the press over the years where it'll come out that somebody, this is most prominently what's happened in professional sports, where a football player can no longer play because he's done damage to his liver by taking a lot of NSAIDs, a lot of anti-inflammatories. Now, that guy probably was taking too many anti-inflammatories, but he probably also had a genetic condition where he didn't break down those very well. So they stayed in the system longer and they did more damage to the liver. So this is the implication of not being able to detoxify in a timely manner. The drugs are going to hang around for longer. Whereas if somebody is a fast metabolizer, and this is all explained when you're looking at the graphic overview, then that person is going to run through these drugs really quickly. You may hear people say, oh yeah, whenever I get prescribed a medication, they always give me a lower dosage because I'm so sensitive. Well, that's kind of a tip-off, because that person's probably not detoxified at the time of life. Or a person who is sensitive to perfumes, oh, I get headaches when I'm around perfumes and they're really oils. Well, that person is likely not processing whatever chemicals are in there and getting them out of their system in a timely method. So I go on in a little more detail here. These enzymes that help you detoxify are turned on and induced by DIM. I presume you've heard of this. This is a substance that's in cruciferous vegetables, right? So you're already, having your people eat cruciferous vegetable. Here's another great reason for you to prescribe those. Much of the health benefits of cruciferous vegetables, when you read about them being effective for cancer and various diseases, come from these chemicals that are in cruciferous vegetables. They basically turn on or speed up the detoxification process. Cysteine, the amino acid cysteine, it's a basic amino acid that's in a lot of these foods that's very good for the detoxification process. Here's a great example of this sort of gene-nutrition interaction. The RARA gene, it codes for a protein that binds vitamin A. So you have vitamins, you have vitamin A in different vitamins, but in order for them to do their work, they have to bind on the cells, right? And those binding sites are genetically coded. So this one codes for the one that does vitamin A. So if somebody was red for RAR, they may potentially have plenty of vitamin A in their system, but it's not binding and not giving the message to the body that it needs. So you would epigenetically, go into that and say, well, you probably need to be taking extra amounts of vitamin A, or even more vitamin A in these foods. Most of our foods are carotene, not vitamin A. Most of our supplements nowadays have carotene, not vitamin A. So that's, a way you can kind of step in there and change the outcome here. There's a whole category around allergies, mold, IgE, IgA, IgG. These, of course, have to do with allergies, they have to do with autoimmune diseases. And again, I have some notes here on the kind of things you can do nutritionally, like if a person is highly inflamed, well, what an anti-inflammatory. Methylation, you're going to start hearing a lot more about if you haven't already. And I don't want to get overly technical about it. I put a little diagram here. This is a relatively, when you look at it from the outside, a very simple system in the body, but it has profound effects throughout the whole body. And you've heard of methionine. Methionine is an amino acid. It's at the top at 12 o'clock there at that middle circle. It goes down and gets processed into homocysteine, and then it goes back up into methionine. So you've got a wheel action going on here. And off to the left, you have folate and B12 that are helping. They're like, you can imagine a little gear clunking in there, and that folate and B12 are helping this methylation cycle move. And what it's doing is it's spinning out methyl groups, little simple molecules that then go out throughout the whole body and turn on and turn off genes, help you detoxify chemicals. Huge amount. Look at a list of conditions associated with low methylation. You can get cardiovascular disease, tendency for stillbirths, spontaneous abortions, depression, anxiety, cleft lip and palate, a huge long list of conditions that are associated with not methylating properly. And you look at the list and you go, what possibly can all of these conditions, what does heart disease have to do with depression, have to do with miscarriages? But it all is because of this methylation process is not working very well in the body. And there's quite a long list of genes that are part of this whole process. And there's a lot of abnormalities in the population around. COMT is a gene enzyme that basically breaks down the neurotransmitters, dopamine, norepinephrine, epinephrine, and estrogen. So this is one of those kind of things where once you start to think about it, it's a little bit of a leap, but then it makes sense. I mean, your body is making these chemicals, right? It's making norepinephrine to help you deal with the stress of your day. It's making estrogen to do things that estrogen needs to do. But your body also has to break those things down. You don't want those circulating indefinitely. And this gene codes for the enzyme that helps break those down. So a person who has problems with their COMT is going to have problems breaking those down. They're going to have more mood swings. They're going to have extra neurotransmitters, hormones floating around in the body that's going to be more likely to set them off, make them nervous, to make them more prone to kind of be stressed out and then hold on to that stress for a long period of time. And by the same token, you wouldn't think this would be related, but it is. But by the same token, those people who are having these mood fluctuations are also going to have trouble breaking down their estrogen because they are chemically related chemicals. And what happens when you get more estrogen floating around? Well, it increases your risk of estrogen-related cancer. So this is a very important hormone a gene to kind of support nutritionally. And the cofactor there is magnesium. So this would be a great place. You probably already know this, but it's, I think, really important to kind of point out this whole issue about cofactors. And this really highlights how important nutrition is. If you're trying to get A and B to combine, to make AB, and you have an enzyme that's being coded by DNA, so you've got this DNA coding for an enzyme that's going to take these two things and make this thing. And this could be serotonin, thyroid, whatever you want it to be, right? But you've got an enzyme there that's doing the action. Well, enzymes all use coenzymes. So they're little factors that help the enzymes work. And cofactors are vitamins and minerals. So that's why they're so ubiquitous in our body. Every enzyme process in our body requires a coenzyme. And there's some, if you ever saw my full report, I have some graphics and stuff that kind of show how technically more how these work. But that's your basic message. So when something like, so when I talk about the COMT having a cofactor of magnesium, well, if this is COMT and we're getting this enzyme and we're trying to break down estrogen into its waste product, we've got to make sure we have some magnesium. And of course, you should know magnesium is one of the most commonly deficient minerals we have because people are not eating those magnesium-rich foods like they used to, the vegetables and whatnot. So sometimes your epigenetic response is going to be, oh, let's add in those cofactors. Let's try it. They have a weak gene here because their DNA is weak. But if we give them more magnesium, it's going to help this action work as better as we can. You're also going to want to cut down on these things that are going in here because the drug isn't doing it. So if we have these catechol, which are epinephrine and norepinephrine and estrogen, and we're trying to break them down, well, that's great. We've got to do that and give some more magnesium to help break them down. But we can also help people lower those by having them do more exercise, or doing more yoga, more meditation. So they're naturally, bringing down these swings in these neurotransmitters And then, of course, if it's a woman, we want to say, you want to be especially careful about taking estrogen compounds because you don't do a very good job of breaking them down and pulling them out of your body. This is one of a number of genes, this COMP, that's associated with breast cancer. One of this next enzyme, gene and enzyme, is a great example of something that I got really excited about when I started looking into this, which is sort of non-allergic reactions to food. You know, you've all seen this. You've all seen people who, wow, eat this and get this reaction. You're scratching your head. Well, is that an allergy? What's going on? And some people, you know, drive you nuts, right? Because they're reacting to all of these seemingly things that are not related and have nothing to do. You wouldn't think would be a regular allergy. Well, there's several genes that are going to help you shed light on this, and this is one of them. So this is the one I was talking about as an example earlier. This histamine, and I have a list here of histamine-rich foods or histamine liberators. You've got histamine. You got the DAO enzyme coding for the diamine octane. In a very simple little enzyme that's in your digestive system that helps you get rid of histamine. This does not affect histamine in your sinuses and allergies, environmental allergies. It's just in your digestive system. And if this is an extreme, another also a great example of how common some of these genetic defects are. I think it was about 3 years ago when I first heard about this enzyme. They were estimating that 30 to 40% of the population had some defect in this gene. So this is before we even started doing lots of testing on people. This is the early research on this. And so they were finding that these people who were eating foods that had histamines or high in histamines and were not breaking them down were having all kinds of reactions. Obviously gut kind of reactions, because histamine is an irritant, an inflammatory chemicals. You can imagine that being in your digestive tract and affecting the mucous membranes of the digestive tract. But it also was having other effects. It was triggering depression and anxiety and mental stuff in people also. There's some very interesting case studies of children, for instance, who lack this enzyme, who are having all sorts of problems, barely function in the world, and then they started taking this enzyme, changed their lives. So your epigenetic influence would be to counsel people. The first question, of course, is, have you ever noticed these foods bothering you? Or send them home to bed as a homework assignment. Watch yourself when you're eating, when you're having wine, when you're having foods that have been sitting in the refrigerator. See if you notice that there's any kind of a trend here towards those foods giving you reactions. If so, then you can say, okay, this is not really an allergy. You're just, building up too much histamine in your body. So let's cut down on these histamine-rich foods. Be careful about letting food sitting in the refrigerator or on the counter because the histamine level builds up. And see if that doesn't improve those symptoms. If they have a minor defect here, that'll be enough, and that can put them into good stead. If that doesn't work, you can do what I do with people is I'll say, well, spend a week taking this enzyme every time you eat. And then at the end of the week, you should have a pretty good idea of whether, I feel a lot better. That's because we're finally breaking down the system. And the Germans, of course, figured out how to synthesize this enzyme. So it's not a regular enzyme. You're not going to see this enzyme in any kind of enzyme that you're buying over the counter for people with this diamine octane. This is the only thing it does. It doesn't break down proteins or fats or anything. It only breaks down histamine. So that's a really, really been a great one. That's why this is so interesting. You get into this whole thing of You can have the worst genes in the world, but eat a great diet, live a good life, happen to have been raised someplace where it's not highly toxic, and not have any problems at all. And then you can be a person who has really lousy genes that are just the opposite, having great genes but living a lousy life and manifesting. Because what the lousy life does, what the toxins do, and foods do, what the alcohol do, is they turn on these genes. You'll actually see references. We don't know all of the details of all of this, but we know that there's several in here that were turned on by like herpes virus and whatnot. So you'll see somebody who lived a fairly healthy life, and then they'll say, God, I got this infection, bad viral thing, and ever since then I've had all of these health problems. Well, that's because that virus made these genes manifest that have been sort of sitting quietly. You know about fauvism? We studied that in school and forgot all about it. The G6PD is the gene that codes for this disease, fauvism, which causes, in severe cases, fatigue and hemolysis, and sort of a blue tint to the skin, dark urine, transient arthritis, and that was first associated with fauvapine, and that's why it's called fauvism. But other beans can do that too, particularly soy. So here again, is the person who's having a reaction to soy an allergy? Is it a digestive problem? Do they have, a problem here with this gene that helps process that? These are all kind of broadening kind of horizons and how to deal with these problems. GAD, second from the bottom there, is another great one in terms of food reactions. So glutamate, normal amino acid, right? We all need glutamate. Glutamate and glutamine are sort of intermixed. I think glutamine is the highest amino acid in our bodies because it's very high in muscle tissue. But glutamate, if it builds up too much, is actually a neurotoxin. And it's supposed to be being converted into, I don't have it on there. Let's do this. So, you're eating food, you're eating protein, you're getting a certain amount of glutamate. Do you know what's particularly high in glutamate? What tends to be high in glutamate is monosodium glutamate. So these are people who go in reactions with monosodium glutamate. It also can be very high in a lot of the processed protein products, whey proteins, soy proteins, and whatnot. Depending on how they process them, can be very high in glutamate. Again, I can't talk at the same time, sorry. So again, glutamine is necessary, but what we really want it to happen is not for it to build up and become a neurotoxin. We want it to go to GABA. And this GAD enzyme, or gene, codes for this GAD enzyme that helps convert it into GABA. And GABA is what? GABA is a neurotransmitter that has a calming effect on the body. So you have these people who have a lifetime of not sleeping well, and being anxious, and not being able to kind of settle down, and whatever else is associated with the sort of neurotoxicity, neuroirritation, and lack of GABA. And you get them to stop eating glutamine-rich foods, and it can change their lives. Or you can give them the cofactors, which are magnesium and P5P. You know about this activation of the vitamins, so B6 isn't really active in the body. It has to be converted into P5. That's part of the methylation process. So it's P5P, activated B6, and magnesium are the cofactors. So somebody who has this condition see, they modify their diet a little bit, they eat more foods that's rich in magnesium and B vitamins. All of a sudden, this next category here at the top of page 7, MTHFR, MTHFRD, MTRR, these are all genes that have to do with folate. This is probably going to be the most likely thing that you're going to hear about first when you start talking to doctors and looking at the literature. And you might even see patients come in and start saying, oh, I had this test done for methylation. And they'll think they've had their whole methylation tested, but really all they've done is this one gene. It has to do with basically taking folic acid and turning it into its active form, and then making transport mediums and things like that. So this is a really kind of fascinating thing that we could go on for hours about, but kind of to relate it to things I think you could relate it to. Some people, it can completely change their world by doing this very simple little thing. Cutting out the folic acids if they're taking any, cutting out the processed foods, which of course you're doing for lots of other reasons too. Having them take, instead of taking a multivitamin with folic acid, you can get ones now with folate. They're a little more expensive, but well worth the money. And then you have them eat a lot of folate-rich foods, and these people won't have a problem. So one of the interesting things here is I was talking about all of the different diseases associated with methylation problems. So we see depression, heart disease, and whatnot. And we see a very high level of this in Italians, but we see very low rates of the diseases associated with this. And you're going, so this is the great, intervention of epigenetics. The Italians, traditionally anyway, were eating a lot of folate-rich foods, and they were living a more mellow, less stressful lifestyle. So the genetics, the bad genetics, weren't manifesting. Now, of course, everybody's getting messed up because of their diet.
There are thyroid, several thyroid genes that are going to make them more susceptible to thyroid abnormalities and autoimmune thyroid disease. And I've got some foods listed there that will help with that. The eyes, I've already mentioned this thing about carotene and vitamin A. Mitochondria, here's something that's coming out more and more in the literature, this idea that the mitochondria, the little powerhouses that are inside of our cells, well, if they're messed up, it's a fundamental thing. It affects us in many ways, most obviously in energy. And so a person who has mitochondrial function will tend to have lower energy, and that can affect lots of things. In conclusion, I'll just say that I just think that this is like amazing stuff going on. I hope I explained it halfway coherently to you. This is the first time I've ever done this. I've written a lot about it, and I've never done it in public before. But I think it's a really valuable tool. And you're either through me or from other doctors, you're going to be seeing more and more about this. And I hope you figure out that this is a really important thing. And don't be intimidated by it, because it supports what you're already doing. It completely supports the importance of nutrition. But it does help you, juggle things around and be a little more specific and figure out some of those things that were making you scratch your head. Questions, please.
Do you mind sharing, since we're doing the recording of this, do you mind sharing now about your, what exactly it is that you do in terms of the reports? Because the reports are amazing.
So, what I alluded to, and I guess I didn't explain very well at the beginning, is that people do their genetics. So this is the basic test. And then they have this huge amount of information that they don't know what to do with. So, and it's all explained in my website and in here, but basically you can go into your 23andMe file, download this data, send the file to me, and then what I do is I produce a report that's 30-some pages long. The first part of it is kind of basic genetic information for those who want to know that. They can skip it if they want. The second part is, this color coding organized graph, which basically goes through their genes and has a little bit of an explanation of what that gene does, some of which is not going to matter much to people, but it's interesting information. And then it talks about maybe the cofactors and whatever, and the diseases that are associated with that. The third part of the report is kind of like taking that information and organizing it into a very specific thing having to do with your genetics. And then the fourth part is suggestions, recommendations. So I would say something like, like with the DAO thing, I would say, the recommendation would be to talk to your nutritionist or your health provider about lowering your histamine intake or possibly taking DAO enzymes. So that would be like a recommendation based on your genetics. So I'm putting it back in, your department, because I don't want to do any prescribing or even any diagnosing based on genetics. That's really not a sound way to do medicine, because we know it's nature and nurture. So what I can give you is a genetic report that then you can take and figure out, what are the main things here? What are the things in the red? How can I kind of pinpoint this for my clients? And I charge $183 for that. It's all done online. They send me their report, and then I go through it, and a week or so later send them back their report, and encourage them to take it to the doctor and the nutritionist. And I have brochures on that. I also have a whole website that kind of explains it also. Does that do a good enough job?
Yes, but if I may interject.
Yes.
So I did this with Dr. Ballard, and when I got the results back, I said, "You are so undercharging." I mean, really, the fact that he's charging $183, I'm hoping that he really increases it. But he could charge. I mean, this is a wealth of information, and personally, I don't know anybody else doing it, especially not a naturopath. There's some MDs that are doing it, but it's very, how can I analyze this so I can sell more drugs? But what Dr. Ballard is doing, where it's very lifestyle focused, nutrition, holistic, I don't know anybody else that's doing this. And personally, I feel like he could charge way more, and this is a huge asset. Because when you get the 23andMe back, I don't know when I got it back, it was like, well, this means absolutely nothing. I know this is wonderful information and it's amazing, but I have no idea what to do with it. So the fact that he's doing this is a huge service, because then you can take it and apply it.
Did you bring your checkbook today? It amazes me too that nobody else is doing this. I mean, when I started doing it a little over a year ago, when basically when 23andMe dropped their price from $250 to $100 is when I started doing this. And at that time, they had a health analysis that they were reporting. And it was fairly decent, but it wasn't really in depth. So, for instance, they would say something like, you have genes that increase your likelihood of having celiac disease, and then you could click on celiac, and it would explain what that is, and then you could click on gluten and explain all the foods that have gluten. So it was a decent little website, but it was very limited, and they didn't go through all the genes by any way, shape, or form. So that's why I decided to do this. Since then, there are companies that are doing similar things. Like there's actually a company here in Seattle that does a genetic testing just for metabolism of drugs. And I think it charges like several $1,000 to tell you if you're a good candidate for taking statins and things like that, or whether you're not going to metabolize them really well. And then there's another company that's been advertising and coming around to a lot of naturopath offices. And they just do the neurological, behavioral part of things. They're not, again, looking at the whole gene. And there's a bunch of them that are doing the methylation part of stuff that you can do for, again, $7,000 and look at your methylation cycle. But amazing to me, I am the only person who's doing the whole thing and, making an effort to say, hey, this is what our genes show us. We should be eating well, we should be supporting our detoxification pathways, we should be doing meditation activities, exercise, all those sort of things that support our genetics. So, I'm out to increase my prices yet.